Well, good evening and welcome to Space Oddities. How are you all this Tuesday evening? Lovely to see you all, and thank you for being here, of course. So first of all, already thank you for your donations that have come in. Much appreciated. As always, as I always say, everything goes towards keeping the channel running, so your donations are much appreciated because we want to carry on doing what we're doing. So let's just have a look in the chat and see who we've got in this evening. Gerard, thank you very much for your donation, sir. Derek, nice to see you. Alan, good to see you as well. Stuart, we've got a few others. So thank you for being here. So we've had a bit of a disappointing week here at Space Oddities. We tried to cover the launch of the Ariane 6 on its second flight and its first commercial payload flight. And that didn't happen for reasons as yet unknown. They delayed it and then scrubbed it altogether. Then yesterday, the 8th test flight of Starship was scrubbed at just a few seconds before launch. And the reason for that, well, twofold, really. They had low pressure in the booster's turbo pumps for the fuel. And that seems to have been caused by ground equipment, luckily. So they've been working on that today. But also the actual thing that aborted the launch of the Starship itself, a fault on the Starship. And that's the thing that actually cancelled the countdown. And we don't know what that was. But you'll be glad to know that the launch is rescheduled for tomorrow at the same time. So that's 10:30 UK time. The launch will be going live at 10:15. And we hope you can join us for that. Then what else have we got coming up? We've got the launch of the new astronomical observatory Sphere X. And its companion Punch, two separate observatories being launched on a SpaceX Falcon 9 in the early hours of Thursday morning. That'll be at 10 to... I can't remember this UK time. I think it's 10 to 4 UK time, if I remember rightly. We'll be up early for that, or late, depending. And we've also got before that, on the 6th, we've got the landing of Intuitive Machines IM-2 lander on the moon, following hot on the heels of the landing of Blue Ghost on the moon. But we'll talk about that a little later because it's been sending back some marvelous images from the surface of the moon. Just let me tell you who we've got this evening. You probably recognize these tired, haggard faces. So we've got Michael and Roger. You're looking even more haggard than usual, Roger. So, and we've got Tom, who is actually only haggard in his spare time. So there we are. And Lou can't join us this evening, unfortunately, because he's in the middle of a NOAA Space Weather webinar. So he sends his apologies. And that's about it for now, I think. So just let's go through the usual stuff before we make a start. Don't forget that if you do want to help us out on the old finances, then you can buy us a coffee, and you can scan this QR code, or you can click the link in the chat, and that will whiz you off to buy us a coffee. Look, we've all got coffee on the go here, so that will enable you to buy us a coffee. And thank you for that. You can also click the super chat icon underneath the main chat window, the one with the $ on it, to make a donation to us directly. And we accept any donations, no matter how enormous. So, please donate away and keep us going as a channel. Yeah. Because it won't be long till we're celebrating our 3rd anniversary here on. That happens the last week of May, so not too long to go till our 3rd anniversary. We'll cook something special up for that.
And we have a nice cream and jelly.
Yeah. We'd also like to announce that we have reached the 500 video mark. We now have 500 videos on the Space Oddities channel. And if you haven't had a browse through our playlists on the channel, go and have a look, because I'm sure there's something there that you will like to watch. So we've actually got 500 videos there, and we're looking forward to the next 500. If, of course, you have any suggestions for videos that we could make, something that you think might be interested for people to watch, any content suggestions, you're more than welcome in the chat, or you can mail us directly and address your emails to info@spaceoddities.space. We're always glad to accept ideas from our audience. So if you have any ideas for content, then let us know about it. Also, don't forget that in April, it's Moon Month here on Space Oddities. We'll be devoting a lot of time on the channel to everything to do with the moon. And you'll see a lot of videos appearing on the channel during the month of April that we're all busy beavering away at making at the moment. We've got a big range of material about the moon, everything from its evolution and formation, space missions, you name it, it's going to be there. So we're looking forward to presenting Moon Month to you. And as this is a frantic year for missions to the moon, we thought it might be nice to sort of celebrate that by having a whole month about it. But we'll let you know more of the details and exactly what's going to be on the channel nearer April. Don't forget as well that we've got the Space Oddities shop where you can go and order your absolutely wonderful merchandise, because astronomers' lives matter after all. So you can get your t-shirts and sweatshirts at the Space Oddities shop, very reasonable price and high quality stuff, as we can all attest to because we've all bought it. And there we are. So again, any contributions via merchandise will be gratefully appreciated. We hope to be bringing you more merchandise items in the future, but more of that when we do that. Okay, well, that's all the housekeeping out of the way. We hope you're all well. We all hope you've had a good week, and we hope you'll stick with us for the rest of the week for the launches and events happening for the rest of the week. Full details you can find on the YouTube channel, but you can also find a description of what's coming up on the Space Oddities website, and don't forget that is https://spaceoddities.space. And let me just put that up on the screen for you, so you can visit us at the website where you can see exactly what we're going to be up to. We've got the viewers gallery on the website, and thank you all this week for submitting a large number of astronomical images.
Huge.
Yeah. Roger has been working overtime, I would have you know, and not your favorite either, because we've been, I don't think swamped is too much of an exaggeration.
You've lost a couple of years, Roger, trying to do that gallery. I can see.
Yeah.
Yeah, absolutely.
I had black hair last week.
Yeah. So thank you. You've made Roger's week, or not. So thank you for all your images, because we love having your images. And don't forget as well, as an added bonus and free, you get your own gallery on the Space Oddities website with all your images in. So the number of submitted images this week has been so big that we decided to hold some of them back to next week. Otherwise, the whole show today will be taken up with the gallery. So if you've submitted an image and you don't see it this week, you'll definitely see it next week. But we've had to sort of cut it in half because there were just so many. So we're really happy with that, and thank you so much for all your contributions. Can I just remind you, if you're going to send an entry into the gallery, I'll put the address up here for you. If you're going to send an image into the gallery, can you please restrict it to one image per email, because poor Roger hasn't worked out yet how to use multiple images in an email. He's still in training. Yeah, I know. And he's only an intern, so treat him with respect. And if you could just try and have one image per email, and do attach them rather than paste them into the email, because otherwise we have to extract it from the email, and it's just a lot of work for Roger. So if you could make Roger's day, as it were, by just putting one image per email.
Wait a minute, is that the smallest violin in the world? Listen.
Yeah.
You did that last week.
Yeah, and if you could also restrict the size of your images to 1920 by 1080, You can send larger images if you want, but it's a bit pointless because they have to be shown at 1920 by 1080. So they get shrunk down otherwise. So if you could do that, that'd be fantastic. All right. Well, obviously the gallery is coming up very shortly. So that's it. What have we got this evening for you? Well, we've also got this evening, obviously, the news. There's been quite a few really interesting stories in the news that I'll be telling you about. Michael's got some news of the FAS and just a reminder about the eclipses coming up. But in time-honored tradition, what we're going to do now is go over to Roger for the look at the night sky and the gallery. And Roger, you'll have to reload your presentation, I'm afraid.
Oh.
Yeah, because you went out and came back in again.
I did.
Yeah, just give Roger a few seconds.
Beg your pardon.
Yeah.
What am I?
Yeah. Also today, this week's constellation of the week will not be happening because a certain person who I won't name, but his name's Michael. I've
had other things on my mind.
Yeah, we know.
Yeah,
this is a family show, right? So probably best not to go into that.
Yes.
Michael's forgotten to do the constellation of the week, so please do forgive him. And if you don't forgive him, you're more than welcome to write an abusive message in the chat. So please do that, because we love reading those as much as we enjoy looking at your images.
Yeah, 100 likes, Michael. I must not forget.
Yes.
Constellation of the week. Yes.
By the way, Paul Bogart asks, Roger, do you have a preferred image format for the?
We can do either JPEG or PNG.
Yes, absolutely. JPEG or
if we're going to do any video time lapses, I'm going to have to present it separately because we obviously can't do it in the PowerPoint. Plus the fact we can't upload the GIFs or videos to our website because it's just a still image website. So
yeah, absolutely.
Unfortunately, some images might not be able to go on there, but apart from that, we're good.
Yeah. So JPEG or PNG, please.
Yeah. Yeah.
So Gerard says, I look forward to seeing a future mission with Trump and Musk sending the pair of them to Mars. So
one way.
Yeah, one way. Yes, obviously. So so there we are. Ian says, how do you send videos? Well, we can, as Roger said, but we can basically MP4 format. We can actually get them into the PowerPoints, Roger. That's not a problem. So
if I present it from my location.
Yes, absolutely.
Right.
Yeah. So there we are. So we can do anything then. So okay then. So let's having reprimanded Roger for his forgetfulness and Michael for his. Oh, sorry. Let's go straight on with Roger's bit, as we like to call it.
Ooh, hello.
Oh, hello.
And Tom's here.
Right. Okay, so we are into the 4th to the 10th of March. So working our way through to the coming of spring. We're currently going through to the first quarter of the moon coming up towards the weekend. So things aren't too bad up in the night sky at the moment, but they are going to be quite affected as it does progress through the week. This was a quick snap I did last night.
Lovely.
That's nice. And a lovely view of the Blue Ghost landing site.
Yes.
Yes, absolutely. Yes. Where are the stars?
Yeah.
No.
There are no stars.
Don't start.
Okay, moving on. So here we are through at 10 p.m. through the week. And as you can see, we've got Orion heading towards the western horizon. Woohoo. But we still got Venus before sunset, and we've also got Jupiter and Mars completing the planets up in the sky. And as you can see, we've starting to get the spring constellations through, with the possibilities of doing a Messier marathon later on this month, with the constellations of Leo and Virgo coming up nicely now. So be aware for that. And we definitely know spring and summer is coming, because we got Arcturus coming up through to keep an eye on.
Yeah.
But we've got Corona Borealis there, so we're still awaiting an announcement from that explosion yet to happen. Somebody's been forecasting that it's due to happen in the next week, but I don't know what tea leaves they've been looking at.
Yeah, I actually saw an article on Facebook from some website today that said, no, it's definitely going to happen in the next week. I thought, no, it's not.
No.
No. It may not happen at all, of course. One never knows.
You never know. So we are working our way through. And I've just got a little layout here of what you could see if we didn't have an atmosphere of the Saturn, Neptune, Mercury, and Venus all following on from the sun here. So obviously we've still got a chance to see Mercury and Venus quite nicely just after sunset, but obviously Neptune is a no-show, and Saturn's too close to the sun now anyway. So bye-bye Saturn for a little while. But next time it appears later on, it would have had its rings edge on. So that could be an interesting sight to see. As you can see, it does get quite close by the latter part of the week. So there we go. Right, okay, so we do have a gallery this week. I've only kept half of the images in. We've got about another 15 of the images to go in for next week, just in case the amount of entries doesn't quite come up to what we normally have. So we will have another quantity of images to come through. Okay, so our first one from Dublin is undone, and these are Kelvin Helmholtz clouds over Howth. Now, if you don't know what they look like, this is what they look like.
Oh, wow.
Oh, gosh. And you've had... Oh, goodness me.
They look like crashing waves. It's just where the wind is over the top, pushing the tops of the clouds over to give them like a wave form. And yeah.
Oh, wow. I'm so jealous. Wow.
Yeah, that's an interesting amount of... somebody will not be able to see that, I'm sure. So Graham, he got out his sea star and took an image of the Pleiades, and that was on the 24th, so it was just about a week ago. So it's only 52 minutes of 10-second shots, and he managed to get this.
Oh, lovely.
Yeah, got some of the nice nebulosity coming up through there, so well done. Very nice.
Beautiful. Well done, Kev.
Yeah, it's all, lots of stars in that one.
Yeah,
well done.
A lot more than 7.
Right.
Yeah.
Yeah, just a bit. Right, and another regular from Jerry of the Bat Nebula, and it's a reprocessing of his image, and obviously he feels a lot happier with this one. And this is the result.
Ooh.
Wow. Got some nice colouring there of the different gases there. Very good. Very nice. Okay, so
beautiful.
Now we've got a series of images from Ian here. This one he managed to get up rather early for a sunrise, which we was hoping to get, and this was the result of the anticipated sunrise.
Yeah.
Another cloudy day in the UK. So there we go. Never mind.
Never mind.
And here's another one which he suggested. Here comes the sun.
Aha.
Slightly thinner cloud on this one.
I see the sun. Sun
I
light.
can start to see the sun. Yes, wishful thinking.
Yeah.
And we've got 1 hour before sunset for this one. And there is some blue sky in this one, so things were looking quite.
Photoshop.
Yeah, right.
Fake AI.
Yeah, fake.
Mm.
CGI.
That looks a bit boggy out there.
Yeah.
And another one where he's got the sun coming through.
Oh, that's nice.
Just be coming through. Yes, very nice.
Yeah.
Mm. And then
That was
we've
on-
got a little triptych here of how
Mm.
the sunset progressed. Very
Beautiful.
That was on Picasso. Ian, thanks for dropping that on there.
Mm.
Nice. Oh, right. Was it? Ooh,
Yeah.
okay. Well done. And then sunrise, by the way, it was in the wrong direction. No sense of north.
What is he saying? The sun rose in the wrong place.
Hmm,
We're
Probably.
doomed. We're doomed.
We're doomed.
But so an interesting sunset shot there. Okay, so here's one we've got saying, "See you tomorrow, Sunny Jim." Oh God, what have we done here? I don't know. I must have forgotten to put the other picture in. But
well.
anyway, oh well. Right, so we've got one from Lee here. So been a while with lack of motivation and clear skies, but he managed to get out between 2 and 6:30 a.m. on Saturday, the 1st of March, with the Milky Way rising over North Cornwall, and this was his result. Look at that.
Oh,
That's lovely.
That's nice.
Yeah.
that's lovely.
This location he has used before, I seem to remember.
Yes.
Yeah.
Yeah. I recognise the fence.
Yes.
Yes,
I like the lead. I like the leading of the fence.
the leading line.
The leading
Yes.
line. That's it.
Lovely.
Yes, that looks a wee bit frosty out there.
Yeah.
Mm.
Wee
Nice
bit
image,
frosty.
Lee. Nice image.
Beautiful, though, Lee. Absolutely.
Is that Sagittarius on the right?
Probably. That's actually
Scorpius.
that's
Scorpius.
Scorpius. Yes, that's Antares over on the
Yes.
Yeah.
on the right there.
That's what I was thinking.
Yes, just a slight prompt. Okay. So Graham did a handheld picture, and he was trying to show somebody what he was trying to photograph, and he says it felt like being a Poundland Patrick Moore, because he was trying to show her the planetary parade.
Mind
And
you,
this
Patrick Moore did used to get his suits from Poundland.
Ow. And we have got the Venus and a nice thin crescent moon there in this image.
Lovely.
Beautiful.
Very, very nice.
Nice
Yeah.
frame.
Lovely.
Okay. And this one I will show you as a separate, because this is a time-lapse animation.
Oh,
If you just...
This posh.
posh,
Yeah.
definitely.
Okay, let me just get
Ooh.
that ready. And
Computation of ion transit of the Great Red Spot. Ooh.
yes, it's quite good. It's basically speeded up 1,000 times.
Right.
Ian
Spread
says his shots were a horror phone, but actually he now connected that to honor.
You mean like a Huawei?
You may be right the first time.
Right. Okay, can you see something?
Just 1 second. Oh, hang on. I just missed the notification. 1 second. Oh, let me put this on.
I have
Okay,
got...
there you go.
Ooh.
Right, I will now play this. It's 33 seconds long, and you'll watch the transits and shadows going across, and the moon's going front and behind.
Oh, that's nice.
Yeah, hang on. So we get one shadow going across, and then you can see another one going behind Jupiter,
Yeah,
and then you've got the other one going in front.
Wow.
that's superb.
That is absolutely superb.
Definitely.
That moon going behind looks like Saturn.
Yeah.
Mm.
Yeah, so you've got one going in front, the other one going behind. So there we go.
Yeah.
Very, very
And you've
good.
got the and you've got the shadow going right across the Great Red Spot as well.
Fantastic.
Great details on there as well, and the temperate zones and stuff. Really, really good.
Yeah. Yeah. So there we go.
There we are. Well, there we are. Well, thank you all very much indeed for
Very,
sending
very good.
these in.
Yes.
Don't forget, gallery@spaceoddities.space is where you should address your emails. And don't need to, but there we are. So thank you. And don't forget, those images are already on our website at spaceoddities.space in your own little gallery. If you click the Viewers Gallery tab, you will see the gallery in all of its splendor. So that brings us on now to the news for this week. And so let's have a look at the news. Just let me set myself up here. Give me 1 second. Okay, hope everybody can see that. So this is the news for the 4th of March. This is the main story that we've led with for tonight's show. The not that one. Sorry, just 1 second. Right. So this is Enceladus, moon of Saturn. And as you may know, Cassini discovered that it has geysers, proper geysers, erupting from it. And these jet ice and water vapor far out into space. And in fact, that material goes to form Saturn's E-ring, which solved the problem of where the E-ring originates. Now, it's supposed that these geysers originate from a warm underground ocean, which is kept warm by the effect of Saturn's gravity on the crust of Enceladus. And you can see in the insets there some Cassini images. The one on the right are the so-called tiger stripes, where this material is actually being ejected quite violently from within Enceladus. And there's a new study that says actually this underground ocean may not exist at all. So this is the current model of the interior of Enceladus. And there's a step-by-step process here. First of all, you get cold water going from the salty ocean into the rocky core, which heats it up. And then it sort of comes out and interacts with the rocks and forming hotspots on the floor of this ocean. And that material is then transmitted through the ocean, localized heating at the ice and rock interface, and the jets of water vapor and particles erupt from the tiger stripes. And in fact, Cassini actually flew through one of the plumes from the geysers, analyzed the material, and it turned out that it was material that had definitely been in contact with rock. So this led credence to the idea that at the bottom of this ocean, there are, or possibly are, things reminiscent of the black smokers on the mid-Atlantic ridge on the Earth. And the black smokers, as you may know, have just about near boiling water, but they are an absolute haven for life that has adapted to the low oxygen and hot conditions. So this might be a good place to search for life in the solar system. But if you'll forgive the pun, the new study throws cold water on all of that. And from space.com, this is a group of researchers from Dartmouth College, and they set out to understand exactly how these geysers form. And they ultimately found themselves suggesting that the observed plumes might not come from a hidden ocean at all, but it could originate from melted surface ice on the moon, challenging the idea that these eruptions are indeed linked to a deep underground ocean. And of course, if that's the case, then it also challenges the idea that there could be life there. Now, they think there are two major problems with the current model. And the first one is that it would be very difficult for a crack going all the way through those kilometers of ice to cut right through to the surface. and it's not clear how that was the water would actually travel up through the cracks. Another possibility is that there's a thing called shear heating, which is friction generated heat from ice rubbing against itself, is occurring along those tiger stripes we saw. And those tiger stripes especially got double ridges around them. And previous studies describe this sort of double ridge formation. It's like what happens on the Greenland ice sheet, where water freezes and thaws and reheats, and it refreezes. It causes these sort of double ridges. And the authors of the study said, as liquid water freezes in a near-surface reservoir, it expands and drives the size of the crack vertically. The mushy zone that we propose could be a near-surface water source, and for that reason, this deep underground ocean on Enceladus may not exist. And as I said, that has implications for the possibility of life on Enceladus, because you wouldn't expect life to be present in this mushy layer just under the surface of Enceladus. Obviously, this is just one paper at the moment. It has been peer reviewed, but it is just one paper. So we'll have to wait and see whether this is supported by any other planetary scientists. It's a shame Lou's not here tonight, because this is really his baby. But there we are. So a bit disappointing if this paper proves to be correct, that Enceladus does not, after all, have this deep underground ocean. Mind you, there are other places in the solar system where we're pretty certain there are these deep underground oceans, particularly Jupiter's moon Europa. We have 2 spacecraft on the way to Europa to study it in more detail, and that is another possible haven for life. And it's all getting very interesting in the outer solar system. Anyway, moving on, the next news item, we are going to have a look at the Blue Ghost. Now, we covered the landing of Blue Ghost earlier in the week on the moon, and this is one of its first images from the moon, and a beautiful image there of the Earth in the sky, the spacecraft in the foreground, but it's been sending back a few. This is the next one, this wonderful image of the shadow of the lander, again with the Earth in the sky. And this confused a lot of people on Facebook, and I mean a lot of people, because I read through a lot of posts about, obviously the universe on Facebook. A lot of people thought that the shadow was the lander itself and saying it was fake because who was taking the photo. But no, that is the shadow of the lander quite clearly. And the next image is a beautiful lunar sunrise taken from the Blue Ghost lander. Amazing image. If you look in the foreground, you can see that the surface of the moon is very different to what we saw during, for example, the Apollo missions. And that is because Mare Crisium, where the lander landed, is a flat lava plain. There's no actual regolith, if you like. It's or topsoil, if you want to call it that. There's virtually none of it in Mare Crisium. It's a lava plain, and this is where the spacecraft has landed. Incidentally, you can see that there was plenty of potential there for the lander to have a failed landing, because we can see some craters there, and the landing system on the Blue Ghost lander was autonomous, and on the way down it actually steered itself away from 2 large boulders that would have been very hazardous for landing. So all of the autonomous landing software worked perfectly and did exactly as it was meant to, put the spacecraft down in a safe place. We are eagerly awaiting more images from Blue Ghost. So the next one, actually connected, is the Intuitive Machines IM-2 lander, which is going to land on the moon on the 6th of March in a couple of days. I just wanted to show you this image taken, a selfie from IM-2 with the Earth in the background on its way to the moon. Stunning image. And again, people on Facebook, oh, it's fake, there are no stars. Well, of course there are no stars, because the photo was exposed for the lander and the Earth, not for stars. So there we are. Next question for you. Why is Mars red? Well, we've all been taught, I think we all learned, certainly I did when I was young, that Mars is red because the rocks are literally rusty. They're covered in iron oxide. This is what gives Mars its red color. Well, we may be wrong about that. We're not totally wrong, but not correct in the way that we think we are. And from the European Space Agency comes this story that the rust or the rusty dust has a much wetter history than previously assumed. And what they've done is they've combined ESA and NASA spacecraft data with experiments they've been doing in the laboratory on replica Mars dust. And these results suggest that Mars rusted early in the planet's ancient past when liquid water was more widespread. And thanks to the fleet of spacecraft that have studied the planet over the last decades, we know that this red color is due to rusted iron minerals in the dust. And that is to say, it's iron bound up in Mars's rocks. And at some point, what the idea is now, is it at some point reacted with liquid water or water and oxygen in the air, similar to how rust forms on the Earth. But over billions of years, this iron oxide has been broken down into dust and spread around the planet by the Martian winds. But iron oxide comes in many flavors, you see, and the exact chemistry of the Martian rust has been intensely debated because how it formed obviously is a window into the environment of Mars at the time, billions of years ago. And linked to that, of course, is the question of, in that case, has Mars ever been habitable? But the problem with the iron oxide component idea is that there's no water in it. And because of this, researchers have concluded that this particular type of iron oxide must be hematite, formed under dry surface conditions through reactions with the Martian atmosphere over billions of years after Mars's early wet period. But new analysis, and as I said, the simulated Martian dust in the laboratory, is much better matched by iron oxide containing water, which is known as ferrihydrite. Ferrous, obviously, for iron, and hydrite for water. This typically forms quickly in the presence of cool water, and so must have formed when Mars still had water on its surface. And this ferrihydrite has kept its watery signature to the present day, despite being ground down and spread around the planet since its formation. And they said that they were trying to create a replica of Martian dust using different types of iron oxide, and they found that the best match for the actual components of Martian rust is ferrihydrite mixed with basalt of volcanic rock. And lead author Adamas Valentinas said that, and he has actually also worked with the ESA Trace Gas Orbiter, which is an orbiter that's been studying, as it suggests, trace gases in the Martian atmosphere. Now, the new picture of how the rust formed on Mars looks like this. So the first thing that happens, number one, iron on Mars' surface reacted with oxygen and water to create rust. The rust was washed into the rivers, lakes, and seas that used to cover Mars. Over billions of years, all of this was broken down into dust, and then wind blew the red dust all over the planet's surface. So we went from a sort of a grey, rocky, and wet Mars to a red, dusty, and dry Mars over billions of years. So this is quite an interesting study, which does fit the data better than the iron oxide models that used before. And if this is the case, perhaps it does mean that Mars was wet for a lot longer than we'd realized. So interesting results from Mars there. Staying with the subject of Mars, you may remember that in 2021, China landed a lander on Mars called Zhurong, and it's made some interesting discoveries that seem to suggest that, as has been suggested in the past, that the north of Mars was occupied by an ocean. And there's strong evidence from Zhurong. There's a picture coming up of Zhurong on the Martian surface. And they found compelling evidence of ancient beaches on Mars, and the lander landed in Mars Utopia Planitia region, as I said, in 2021. And they've identified key geological features that resemble shoreline structures formed by ancient waves and water currents, exactly as we see with extinct shorelines on the Earth. They detected sedimentary deposits and ridges that match those found on Earth's coastlines, reinforcing the idea that Mars' northern lowlands were once covered by an ocean. And they've given this ocean a name, and it's called Deuteronilus is the name that they've given to the ocean. I know not why. And of course, the presence of this large, stable body of water would have provided a critical ingredient for microbial life. So this could guide future missions for searching for ancient microorganisms. But they think that this ocean did dry up as a result of climate change about 1 billion years into the history of Mars. So so there we are. So interesting results from China about the ancient history of Mars. This story about there being an ocean in the northern hemisphere of Mars has been going around for many decades. There's been tentative evidence for it, but here's the first real concrete evidence that there are ancient shorelines of an ocean in the northern hemisphere of Mars. Good news for India. They launched a solar observatory. We did actually cover the launch live of this, called Aditya, and it's seen an X-class solar flare on the surface of the sun. And this is what it looks like. And it's really high detail from this spacecraft. Among the instruments on Aditya is the Solar Ultraviolet Imaging Telescope, or SOOT for short. And this observation actually happened in February of last year. I don't know why it's taken so long to publish the results exactly, but it's an X 6.3 flare, which is a really strong flare. And it emerged from an active region on the sun, which had appeared just a few days earlier. And the SOOT instrument observed a brightening in the near ultraviolet wavelength of between 200 and 400 nanometers, which this had never been seen before, as there are no dedicated space telescopes focused on this particular wavelength range. And by combining data from the SOOT instrument with observations from another instrument on the probe called SOLEX, the Solar Low Energy X-ray Spectrometer, they concluded that the brightening in the lower atmosphere was directly linked to a rise in the temperature of the sun's corona. So that's quite interesting. So congratulations to India for these wonderful results from the Aditya Solar Observatory. And then finally, just something coming up in the future. New Horizons is going to cross the termination shock. That is to say, the area where the sun's solar wind slows to subsonic speed and slams into the interstellar medium. And Voyager 1 crossed the termination shock about 20 years ago. And New Horizons is going to follow suit probably sometime between 2026 and 2027. Now, the spacecraft is in hibernation mode at the moment, but it's still collecting heliophysics data, which it's storing on board. And Alan Stern, who we've actually spoken to, I think, no, it was on Astro Radio, wasn't it? I think when we had Alan Stern as a guest.
Yeah, I think so.
Yeah. So Alan Stern is a principal investigator for New Horizons, and he said that the probe went into hibernation mode on October the 3rd last year, and on April the 2nd they're going to wake it up again and transmit all of that backlogged heliophysics data back to Earth. And he says, but actual crossing of the termination shock, the timing is a guessing game. Nobody can fully predict that, but it could be as early as 2027. And obviously they want to wake the spacecraft up because they don't want to miss it. But the good news is that New Horizons is in perfect health, and all the instruments are working as well as they were when the spacecraft launched. So they have a working spacecraft. Now, unfortunately, you may remember that New Horizons flew by the Kuiper Belt object Arakoth a few years ago, and they really would like New Horizons to visit another Kuiper Belt object, but there's nothing in its path, and they haven't really got enough fuel left on New Horizons to divert its path to any Kuiper Belt objects that it might be within range of. However, having said that, we've got the Vera Rubin telescope coming online, should be late this year. That is the ideal telescope to search for these pinpoints of light that are Kuiper Belt objects that New Horizons might lay in the path of, that it might be able to visit without diverting its trajectory too much. So we'll have to wait and see. But if that happens, that would be wonderful. One thing that New Horizons has already discovered about the Kuiper Belt is that it seems to extend much further out than we thought. And there's also the tantalizing probability that there are two Kuiper belts, an inner belt and an outer belt, separated by a gap. We obviously don't know why, but preliminary results from New Horizons seem to indicate there might be two Kuiper belts out there at the edge of the solar system. So there we are. So exciting times coming up for New Horizon. Interestingly, when it does pass the terminal shock, the actual moment it passes could last as little as 10 minutes. So they obviously don't want to miss that. It could be longer, but it could be as little as 10 minutes. The point where the sun's solar wind slows to subsonic speed and slams into the interstellar medium, and that will indicate truly that that it has passed the influence of the solar wind. And as I said, Voyager 1 has already done that. Voyager 1 being our first interstellar spacecraft as well, making its way out of the solar system. And Voyager 1 is going to rendezvous with, or go fairly near, the star Sirius in about 36,000 years. So don't set your alarm clock for that, obviously.
No.
So there we are. So that is the news for this week. Anybody got any comments, panel, about any of that? No. Okay.
No.
All right.
Very good.
Thank you, Alan, for your donation. Much appreciated, sir.
All right.
There and there we are. Right, we're going to go over to Michael now. Michael has got a few things for us.
Yes.
What have you got for us, Michael?
Just bear with me. I'm going to share my screen. Okay. So here we go. First of all, do you want to make that larger? Is that it?
That's it. That's as much as you're going to get, mate.
Okay. Right. First of all, it's about the total eclipse of the moon on the 14th of March. This is going to be really for our American viewers because the actual eclipse, the umbral part of the eclipse does not begin until after the daybreak on the 14th in the United Kingdom, but it will be completely visible in the Americas. So these are the timings I've got the eclipse. Just a diagram to remind ourselves what the eclipse is. The sun will block the the sun. Sorry about that. The moon will go through the shadow of the Earth. So you'll see a deep red. The moon will turn a deep red colour because of the refraction in the Earth's atmosphere. So, otherwise known as a blood moon.
And it's worth pointing out it doesn't always happen. It depends on the amount of dust in the atmosphere.
Yeah.
So some years are better than others.
Good point. Yes. So just a few timings here I've just chosen the eastern United States as one of our panel members from that area. So this is from the Pittsburgh, Pennsylvania area. It's going to be 6 hours and 2 minutes long, with a totality of 1 hour, just over 1 hour and 5 minutes. The penumbral begins on the 13th of March at 23:57, partial 14th of March 0109, and full eclipse starts at 14th of March at 2:26. So maximum 2:58, and the full eclipse ends at 3:31. So that's mainly for our American viewers. And of course, if anyone can get any photos of the eclipse, we'll be pleased to see them in the SpaceOddities gallery. So that's on the 13th to 14th of March. Okay.
Great.
This is what happens in the UK. Unfortunately, the local maximum part of the eclipse starts at 6:20 a.m. Our time, and the sunrise is at 6:25. So basically, we're not going to see the full eclipse from the UK, unfortunately. So
what a shame.
yeah, okay. Got to wait for the next one. Right. And just to show that most of the Americans will be able to see this eclipse, the darker areas are where the eclipse will be visible from. So if you're in the United States and Canada area, great, you can see that eclipse on the 13th and 14th of March. Okay, next one is the partial eclipse of the sun on Saturday the 29th of March, starting at 10:30 GMT, or rather, this is an image of what it will look like at 10:30 GMT, and this is what it would look like as viewed from Darlington in the UK. 11 a.m. GMT is the maximum part of the eclipse, and then 11:30 is when the eclipse, the latter part of the eclipse, takes place. So yeah, that is the eclipse on Saturday, the 29th of March. So it's a good time. It's a Saturday as well, so hopefully lots of people will be able to see that. I know one or two societies are going to cover it. We're hoping to cover it on SpaceOddities, but we'll see how that goes near the time. So we're able to bring you that a live show for that. But yeah, that's another thing to think about. The eclipse, GoStargazing.co.uk in collaboration with First Light Optics and Astronomers Without Borders are making available 75,000 pairs of solar glasses for this eclipse. And it's easy to get hold of. There's a website link there, which I can put in the chat in the vis, to order these glasses. And I do believe it's something like £10 for 50 pairs. So it's a brilliant offer, really. So you can get enough for your whole society to actually watch the eclipse, plus a few members of the public too. So never look at the sun without any optical aid, proper eclipse glasses or filters. It can be quite damaging to the eye. So always.
Yes, may I just interrupt there for a second, Michael? Yeah, don't take that warning lightly, because on the 12th of February 1970, there was a partial eclipse of the sun, and I was only young, and I stared at the sun with my eyes for far too long.
All right.
I've had spots in front of my eyes ever since. So,
all right. Yeah.
So, that's affected my vision for life. I was young, and stupid, and I didn't listen to Patrick Moore. So yeah, do be careful with your eyes. You've only got one pair.
Definitely. Yeah. Definitely. Just a one shot with your eyes on. Yeah. No, so take care of your eyes. Okay, so this is just a shot showing what the glasses look like with the solar filters on there. These were produced for the 2017 eclipse, and that's Neil Sanders of Go Stargazing modelling those glasses for us. very similar to that kind of setup. So I'm not sure how many they've got left. I know they've had quite a lot of orders so far, but I'll put that link in the chat so you can have a look later. Just another thing to remind you of, a couple of weeks ago I told you about the FAS convention, which originally was going to take place on the 17th of May. Now is to take place on the 31st of May. Slight change of date there, so it's the last Saturday in May, is it now? And it takes place at the Institute of Astronomy in Madingley Road, Cambridge. So we've got quite a few different speakers which we'll go through in a minute. The tickets for FAS members, I think that is FAS member societies and their members, is just £10 per person, plus booking fee. I think works out about £11.55 altogether. But yeah, so we're asking you to bring your own lunch to keep costs down. We'll provide hot and cold drinks and biscuits available in the intervals. So also during the lunch break, there'll be tours of the facilities with the telescopes, the observatories at the institutes as well. So that's always worth having a look at. So just a word on the speakers. We have Lord Martin Rees, Astronomer Royal, with a talk about the future of astronomy. Will this next century be our last? Then we have Dr. Paul Daniels, member of the RAS, and with a member of Mega Constellations working group, with a talk saying on threats and challenges to astronomy. Dr. Louise Devoy, Senior Curator of the Royal Observatory Greenwich, the history of the Greenwich Meridian. Dr. Matthew Bothwell, Public Astronomer, Institute of Astronomy, the Invisible Universe, the Search for Dark Matter. And Simon Banton, an independent researcher on Stonehenge, Archaeoastronomy of Stonehenge. So that's some good titles there. I just want to remind you about Capcom as well. I've just published the latest issue of Capcom for March 2025. That's a copy of the cover there. If you already signed up for that, so you should get that in your email today. If not, just send an email to Capcom at SpaceOddities.space and asking to sign up for it. It's free. And it's published once every 2 months. So you may remember it 4 weeks ago, we did a special show for schools where we got kids to ask astronauts Anna Menon and Sarah Gillis from the Polaris Dawn mission to answer the questions from the school kids. And there's a 2-page transcript of some of that show. In that edition of Capcom, so well worth a read for that. So yeah, so that's Capcom for you, and I think that's it. Right,
thank you. Talking of Capcom, let's just go and have a look on the website for a moment, because I just wanted to show you, so that you know that we speak the truth. That is to say that this is the viewers gallery on the website, and as you can see, all of our contributors have got their own little gallery on the website. So if we look at Anne's wonderful photo, Anne's photos will appear here, and if you click on an image, you get it full size and the description and the date and everything else. And if you click this icon here, you get to see it full screen. So I just thought I'd show you that. And talking of Capcom, on the website, there's Capcom. You just, at the moment, you just need to send an email to Capcom at SpaceOddities.space and put the word subscribe as the subject of the email, and you'll be added to the subscription list. I am working on a button to subscribe directly on the website, and that will be appearing before too long. So there we are. This comes. Michael has produced this for 20 years. It comes out every 2 months. and it's always a wonderful read. So make Michael happy. Go and subscribe to his wonderful Capcom magazine. It is free, and let me tell you, in all seriousness, you won't find a magazine that you pay for of much higher quality than these. So it's a really good read if you're at all into spaceflight and rocketry. And there we are, and we offer this free to you as Space Oddities viewers. So just go to spaceoddities.space and go to Capcom magazine, and obviously keep those images coming in to the studio here. And thank you very much for all of your contributions. Okay, right, before we start winding things down for today, does anybody have anything they want to say? No?
I read an article today that astronomers have just found in the last few weeks an FRB coming from some dying galaxy somewhere, which is quite interesting. I don't think we've had one of those discoveries for a few years yet. So.
Oh, right. Right. And yes, I was also reading last night, didn't have a chance to get into the news today, that there's something strange in Ursa Major. What they've discovered is something that is just a few stars, not many more stars than the Pleiades. And they blend in so well with the other stars in Ursa Major that they weren't spotted as something in their own right. And when they analyzed the redshift of these stars, they found they're right on the edge of the galaxy, and they're all moving in the same direction, and they are all about 10 billion years old. So really, really ancient stars.
All right.
Now, this is very unusual because obviously something has been keeping that group of stars together and moving in the same direction for 2 billion years. And there's not enough mass of those stars for it to be attributed to the mutual gravity of the stars keeping that little cluster together. And it looks like an open cluster. And what they think it is embedded in a cloud of dark matter, which has kept the stars together for 10 billion years. Wow. And if you want to look this up, this is called Ursa Major 3, that 3 as in Roman numerals, III. And it's very, very interesting. This has never been spotted before, but it's right on the edge of our galaxy where you normally find globular clusters. So very interesting find there. And it's yet another really convincing piece of evidence for the existence of dark matter, because there's literally no other explanation for how this group of stars has managed to stay together for 10 billion years. So there we are. That's an interesting.
Do you think we'll ever get to see a picture of what dark matter looks like?
No, it's impossible. It's impossible because it doesn't radiate any light, it doesn't reflect any light, it doesn't absorb any light.
So not even using any potential technological advancement in 50 years' time, we'll never get to see what it looks like.
If it doesn't reflect, absorb, or transmit light,
we'll never get to see it.
Never get to see it. It's impossible. It's like gravitational waves. Yeah, you can't.
And I take it it's not dark matter.
Well, yeah, absolutely. So I don't think. I mean, never say never, because the future is a long time. But I think we'll see representations. Well, we already see representations of where it is.
Yeah.
But as for seeing it itself, I somehow doubt it. On the other hand, because we don't know exactly what it is, we don't know if we could develop a technology that would enable us to see it.
Yeah.
But it's almost certainly some sort of particle. Maybe axion, maybe something else. But time will tell, Tom. Time will
tell. Yes.
Yeah, indeed. But interesting times. I think. I mean, the hunt for dark matter has been going on for so many decades now.
Yeah.
Since Zwicky put it forward in the 1930s, I think.
Oh God, yeah.
Yeah. So we're nearly 100 years searching for dark matter, which is quite the thought. Admittedly, we haven't had the technology to search for it seriously for the time. But the thing with dark matter is you can only narrow down what it can't be. And that narrowing down is getting more constricted and more constricted and more constricted.
Yeah.
So, if all goes well, we'll be left with, just maybe one or two candidates. The most promising one is these particles called axions. But detecting them is very, very difficult. But there are experiments underway and being designed specifically to look for axions, because it seems the most likely candidate at the moment. Of course, if Lou were here, he would tell you that it's all nonsense anyway, that it's all MOND, modified Newtonian dynamics.
Oh, that's right.
There is no dark matter particle as it is.
Okay. So Lou's a non-believer then.
Well, he and I have actually got plans here on SpaceOddities to have a dark matter versus MOND debate. We sort of do that. So that I'm playing devil's advocate, to be quite honest, because I remain to be convinced either way. If the evidence and the observations say that it's not dark matter, I'll accept it.
Do you think there'll be any surprise? Will there be any surprises that come out of that? Do you think, if there's any other discoveries made or anything? No. Maybe
well, there've been tentative signs. In fact, there was a paper I think I reported on about 6 months ago that gravity does indeed behave differently at very low velocities. And they've looked at these binary stars, where one binary star is a very long way from its companion, still held there by its gravity, but moving very, very slowly. And there's evidence from that suggests that it's not behaving as traditional gravity says it should, and therefore that perhaps we need to revisit the way we think gravity behaves at very low velocities. So interesting times.
So here's a daft question then. So what is causing the Milky Way and Andromeda to collide in a couple of billion years? Is that gravitational pull?
Yes,
it is.
It's their mutual gravitational attraction. Yeah.
So they're pulling because of that, essentially, together.
Yes, that's right. Yeah. There's no mystery attached to that. It's just gravity doing its thing.
Right. Its thing.
Yeah, doing its thing. No mystery there. And in fact, the outer reaches of our galaxy and the outer reaches of the Andromeda galaxy have already made contact.
Really? I didn't know that.
Yeah.
Is that right?
Yeah.
Wow.
Because the material that comprises a galaxy extends a lot further out than the actual visible galaxy itself. There's very, very tenuous material surrounding a galaxy that is, many, many light years across.
Is that like flux nebula stuff?
Astronomers believe that we've already made contact with the Andromeda galaxy, even though the galaxies themselves won't collide for 4 billion years, I think. So that's quite interesting.
So is that so when I image other galaxies, you get this IFN, this kind of flux nebula, integrated flux nebula?
I mean, it's incredibly tenuous.
Yeah.
But it is there. So
Wow.
So there we are.
Interesting.
Ian says, there's no controversy about which side of the fence he's on. Ian says, down with MOND. So there you are.
Fight.
Yeah. I mean, if you've got any, ideas about this, any opinions, don't hesitate to put them in the chat.
Yeah.
Because, it is a debate to be had. And what seems to be happening at the moment is that it could be both. It could be dark matter that applies in some arenas, if you like, and MOND applies in others. So what we're looking at could be a mixture of dark matter and MOND.
All right.
So it could be this gravity behaving differently at very low velocities, plus the particles of dark matter for everything else, for example.
So where does dark energy sit in all that mix then?
It doesn't. Completely different.
Completely separate.
Yeah. Dark energy is that mysterious force responsible for accelerating the expansion of the universe.
Okay. Right, okay.
Now, this was first predicted by Einstein, briefly, because, you see, Einstein didn't believe in the expanding universe. And he actually introduced, if you like, a mathematical fudge factor into his equations to stop the universe expanding.
Oh.
And this is known as the cosmological constant.
Yes.
Now, he later realized his mistakes and took it out of his equations again, and indeed later called it the greatest mistake of his professional life. Yeah, true. But it seems that dark energy has many of the properties that Einstein attributed to this cosmological constant. So Einstein may have been right after all. Not in terms of the universe not expanding, but mathematically it's very similar. So I don't know. The thing about dark energy is that other than being this sort of force, if you like, forcing the universe to expand more rapidly, we have no idea what it is. Absolutely none. And the weird thing about it is that as the universe expands, the density of dark matter doesn't change.
So my question is, why can't they be intrinsically linked then? If we don't know what it is surely there must be something tying it together. Do you know?
Well, other than big question marks, we don't know.
Yeah.
It doesn't seem to be related to dark matter in any way. But, conceivably,
could dark matter be this stretchy thing that's been pulled by dark energy?
Well, no, because we can look at maps of where the dark matter is, and dark matter is not absolutely everywhere. It does clump together. Whereas dark energy seems to be an intrinsic property of space-time itself, and not at all related to particles or anything like that.
True.
So it's something in space-time itself. And even more interestingly, it didn't actually start to have an effect until about 6 billion years after the Big Bang. So for the first 6 billion years after the Big Bang, the universe was slowing down in its expansion, as you would expect, and that's what everybody expected. But then in the 1990s, it was discovered that these distant supernovae are a lot further away than they should be, according to that deacceleration, and therefore the universe must now be accelerating in its expansion. But why did it only happen 6 billion years after the Big Bang? So something happened 6 billion years after the Big Bang, some sort of phase transition. The universe underwent a change throughout its fabric, if you want to call it that. And dark energy started to dominate. Whether it will continue to dominate in the future, we've no idea. But if it does, it means definitely the universe is going to expand, getting faster and faster and faster, and forever. So
to the point that there's the chat about the cosmic horizon, I guess, that it'll go beyond the point where we'll be able to even see it anymore.
Well, but what it means is that the cosmic horizon, the point where we won't be able to see any more galaxies in the night sky, that's going to arrive sooner. So interesting times. Times. Right. So there we are. So that's enough rabbiting on for this evening, I fancy.
No.
So there we are. Anyway, we hope you've enjoyed yourselves tonight, viewers. Thank you so much for your donations. We do appreciate it. We will be back tomorrow for the launch of Starship, 11:30 UK time. We'll be going live at 11:15. If anything changes, keep your eye on the channel, because that's where we will update in terms of dates and times. It's been very difficult this week to keep that updated because of all the changes. But at the moment, as it stands, the Starship's due to launch at 11:30 UK time tomorrow night. We hope you can join us for that. And as I said, we've got the landing of IM-2 at the south pole of the moon on the 6th. We've got Sphere X and Punch, the new solar observatory consisting of 4 satellites about the size of a suitcase, specifically to observe the sun's corona. That's launching as well on the 7th. And I think that's about it, isn't there? Oh, we don't know about Ariane. They haven't announced a date for the launch of Ariane, as I said earlier. So from all of us, from myself, from Michael, from Roger, from Tom, thank you so much for being with us. We do appreciate your time. And we'll see you hopefully at some point over the next couple of days. But you've been fantastic as ever, viewers with your donations and contributions. So thank you very much, and we will see you very soon. So from all